Hi, you rates. This is Mr. Croft, and this is your lesson on atoms. We're going to go through the PowerPoint together. I'll ask you to pause it at several points to answer some questions, and I'll try and explain as best as possible the key ideas that we need to get across in terms of atoms. So, start off, there are three questions on the slide here. What do you think an atom is? What do you think an element is? And what is the periodic table? You can pause the video now, make a note of your answers to those three questions. We'll come back to those at the end of the PowerPoint and we can see how our learning has developed. Okay, so pause the video now and answer those three. Right, so atoms are very small. This is a bit of an understatement because this is generally the smallest size of any element that we can have is an individual atom. So if we were to compare the size of a helium atom to a tennis ball, this is a helium atom on the left here. If we were to imagine that instead of being the size that it is, it was the size of a tennis ball, then essentially it would be like comparing a tennis ball to the size of the Earth. Okay, so that's just an idea of trying to get it into perspective just how small atoms are. Okay, very small. So everything is made from atoms, including you. They are tiny particles, far too small for us to see, even with a microscope. If people are the same size as atoms, the entire population of the world would fit into a box about 1,000th of a millimeter across. So how many 7 billion people in the world into a box 1,000th of a millimeter across. Now, this diagram here at the bottom shows how we usually imagine atoms, and you have seen diagrams like those before when we've done particle diagrams, these ones representing a solid here because they're tightly packed. So when we're thinking of atoms, we go back to the ancient Greeks. They theorized, so they came up with the idea that everything was made of fire, earth, water, and air. Only after 1,600 years did scientists realize matter was composed of different elements. Seems fairly obvious to us now, but back then wasn't quite so. So this man, John Dalton, in 1805, refined a vague idea that matter was indivisible. Okay, if you think back to your maths vocabulary, divisible obviously means they can be broken into smaller pieces. Indivisible cannot be broken down any further than it already is. So he proposed explanations for some observations he had made during experiments. He developed an atomic theory. He was one of the first people to come up with an idea about atoms, but our thinking of atoms has developed considerably since he came up with his first theory. So first, elements are made of extremely small particles called atoms. That's our key word for this lesson. So that's how elements are broken down. Atoms of a given element are identical, so they're the same in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. Okay, so there are different elements, different atoms for different elements. And this is one key idea that separated his atomic theory from previous thinking as well. Atoms cannot be subdivided, created, or destroyed. So they cannot be separated into smaller pieces. They cannot be created. They cannot be destroyed. And atoms of different elements combine in simple whole number ratios to form chemical compounds. Okay, again, that's something that we'll look at in a bit more detail later on in this unit. In chemical reactions, atoms are combined, separated, or rearranged. Again, not created or destroyed. They just change some of their positions. So to make diagrams more simple, we draw them as circles as we've done before in particle diagrams. This isn't a really accurate representation of what an atom looks like, but it's to make things simple. Okay, we don't need to think about too much detail about the structure of the atom when we're drawing bigger diagrams like this. We will do some atomic drawings later on. So one atom on its own does not have the properties of the element. So gold atom is not yellow, it's not shiny, it's not solid or liquid or gas. It is just an atom on its own. So in this picture here, This piece of gold has a mass of 1,000 grams. It is made up of this many atoms. I'm not going to attempt to explain what number that is. So a huge number of atoms need to be grouped together in order for an element to show off its physical properties. Okay? Right, on a separate document that your teacher should have shared with you, there is a murder mystery for the murder at the manor. Okay, these are all to do with different elements, and there is a lot of information provided. What you need to do is try and read through as much of that information as you can to come up with an idea about what you think has happened at the manor. So on the first page, it will describe the problem to you, what has happened, and then it will give you information about the different elements that were present at the party. You can either pause the video now and do that while it's fresh in your mind, or you can wait until the end of the video to do that. It's up to you. So what is an atom made of? Key bit of information that we need to know. So all matter is made up of particles called atoms. These atoms are made up of even simpler subatomic particles. So subatomic means that they are less than an atom. They are smaller than an atom because they make up atoms. 3 key particles we need to know: protons, electrons, and neutrons. You may well have heard some of these terms before, and we need to be able to identify what they are and how we can represent them in a diagram. So my challenge for you now is to draw the diagram down at this bottom right here and try and add these labels. So nucleus, proton, neutron, electron shells, and electron. Have a go. It doesn't matter if you miss things off or you're not sure about some, because we're going to look at the answers together on the next page. Okay, but try it first and then you can add to your diagram when you see the answers. Okay, pause the video now and have a go at that. So an atom is made of protons, neutrons, and electrons, and at the center of an atom is its positive nucleus. So this circle in the middle here is the nucleus. So all of these little circles, the red and the blue, are part of the nucleus. It's in the middle of the atom. Nucleus is made up of positive protons and neutral neutrons, and it's surrounded by electrons. These are arranged in layers or shells. Sometimes these shells are also called energy levels. So if you did your diagram before, the nucleus, as I said before, is this black circle in the middle. Protons are the ones with the positive sign because they have a positive charge, the red circles in the nucleus. Neutrons have no charge, so they are blank blue circles, again in the nucleus. The electrons have a negative charge. They are the minus symbols in the black circles going around the outside. And these are both electron shells. So we've got one electron shell here and another going around the outside of it. Okay, so it's possible to have even more electron shells. Again, that's something that you'll look at probably in year 9. So this is the information that we need to know about what atoms are made of. So you need to know the 3 key subatomic particles: proton, neutron, electron, that we just saw on that previous diagram. You need to know what their charge is. So a proton has a +1 positive charge, neutron has no charge, 0, and electron is -1. It's got a negative charge. The relative mass, protons and neutrons are both 1. This is relative mass, so it's not a scale, it's not grams. It's just a relative to the other particles. These are both the same. We both consider those to be 1. The reason that we use relative mass is because the mass of all of these particles is so tiny, it's very, very difficult to measure. The last one, electron, is generally considered to be about 0. is actually, compared to the other two, 0.0005, but because it's such a small mass, we count it as 0 generally. And where they're found, so protons and neutrons are both in the nucleus of the atom, and the electron is in shells surrounding the nucleus. Okay, key bit of information. If you want to write down any notes, then you can pause the video now to copy down these key bits. Okay, this table is very, very important, not just for this unit, but also moving on to year 9 and 10 as well. Okay, so we've come to the last page of our PowerPoint, and I want to go through and revisit these 3 questions that we looked at the start. So what do you think an atom is? Hopefully now you'll be able to have another go at this, and we should be able to identify that an atom is the simplest form of an element. So if we break down an element into the smallest possible pieces we can, we'll be left with an atom. An element is a combination of one type of atom. It has only one type. That is the key bit of information. So if I've got gold, I've only got gold atoms. If I've got silver, I've only got silver atoms. And then 3, what is the periodic table? The periodic table we'll look at in a later lesson. That is where we'll find information about all the different elements that we are aware of. Okay. Right, I hope this video is useful to you. There will be a few more questions on the Google form following this that you will need to try and complete. If you need some extra help with anything, go back through the video, look at the PowerPoint. You don't have to watch it all, just click to where you think you need to go. Or try and do some of your own research to try and find the answers. Okay, right.